Hello, and welcome to the No Bad Questions podcast, where I try to learn in a conversational manner, to break down jargon, and to present the least amount of filtering as possible on a wide array of topics. I hope that you learn something too. If you do and want to support the podcast, you probably already know all the ways that you can do so. You can like, share, subscribe, hit the notifications, but ultimately, and what I hope you choose to do, is watch to the very end. With that, we'll start today's podcast. Hello and welcome to this week's episode. I am joined this week by Adam Becker, who is an associate professor and the department chair of mathematics for Tidewater Community College. Adam did his undergraduate work at Appalachian State in math, philosophy, and religion. He says, being from Iowa, he's a fan of any non-flat geography, so he stayed in the mountains and did his MA in math, also at Appalachian State. From there, he went to Florida State, so back to the flat a little bit, Adam, and finished an MS in financial math with a concentration in quantitative finance. So we're going to be talking about statistics and mathematics today, but for some more context, Adam enjoys powerlifting, kiteboarding, wrecking kids at go-kart tracks, mountain biking, mead and winemaking, and Spartan races, and we've got a great one of those up here near me in Ohio. He's a four-time survivor of the running of the bulls. I'm not sure if that lines up with the statistical averages for surviving running of the bulls. Maybe we'll get into that. But he lives on a small homestead with his partner, his stepson, quote, a very low IQ dog, a sociopathic cat, and 12 ferocious chickens. Adam, thank you all the way from the homestead being here on the No Bad Questions podcast.
Yeah, I appreciate it, man. Thanks.
So I've heard it quoted many times, I believe it's attributed to Mark Twain, that there's three types of lies. Mm-hmm. Lies, damned lies, and statistics. So is there truth to that?
I can see how there would be truth to that. In maybe not in the US, but at least in my opinion, how I would interpret that. If there is kind of a reverence for science as like the foundation of truth and knowledge, and people view statistics as a scientific process, I could see how people would just, oh, well, there's a study here. It's true. It's got to be true. But I would imagine what Twain was probably getting at, and I would hate to put words in his mouth.
Sure.
But it is awfully easy to lie or deceive with statistics with malicious intent, but it's also very easy to inadvertently lie. Or not. I guess that wouldn't necessarily be a lie, because I'm sure.
Yeah, in that case, perhaps just
screwing up, I guess.
Yeah.
Mislead people accidentally.
Right.
There's another quote out there that I've heard, and it was statistics is the only discipline in the world where two people can take the same data set, the same tools, arrive at completely different conclusions. So I can see how that happens, or how someone would feel like that. And it is a huge problem. Some of it comes down to, like I mentioned, malice. But on the other side of that, a lot of it comes down, and I'm not saying ignorant in a bad way, but just uninformed. Like, people don't know how statistics work. So what do you do when you're just completely, and like you mentioned, election season, you're nonstop bombarded with statistics. Right. So I guess I just believe them. Like you just throw your hands in and it's like, okay, all right. Well, I guess if I have 2 cups of coffee for the next 5 years of my life, maybe my risk of heart attack goes down. Or if I eat enough chocolate,
that's
things
a
like
fun
that.
one. The dietary ones, right? Chocolate is good today, it's bad tomorrow. Coffee is have some, but don't have too much. Wine, just I feel like every week there's something that goes one way or the other.
Yes.
In dietary studies. And so
Sure.
If I'm hearing you right, you think a lot of that comes down to the data and interpretation around statistics. So let's break that down for folks. You said, it's the only discipline where people could take the identical set of data and arrive at two conclusions. How the heck could that happen?
Okay, so, well, going back to the dietary stuff, there is a wide gulf between, I would hate to say two types of statistics, but two types of methods. One is a designed or a controlled experiment, and the other side of it is kind of an observational process. And one of the big issues with statistics, and especially what you see in the media, causality. Causality is the issue. And you can only get causality when you are conducting an actual experiment, right? So you grab your group of people, and we'll just use the pharmaceutical experiment, right?
Sure.
Someone's trying to get FDA approval for their new miracle drug. You grab two sets of people. You have your control group, you've got your experimental group. You actively interfere in these people's lives. It's like, here you go, you're getting this drug, and then these people get the placebo. Hopefully it's done well enough to where nobody knows what they're getting.
Right.
Okay. And then you get the data in the end to test, whether or not your new drug is, effective at all. And I would hate to just make up some percentage off the top of my head, but I would say almost everything you see in the media that's related to dietary stuff, that's related to, coffee, wine, chocolate, whatever, do this and this will happen. Not one of those things are ever done in an experimental fashion. They're literally just, some of them just calling people and just say, hey, you eat chocolate, or, and then they kind of follow these people through their lives. Well, a lot of people live different lives, a lot of different lives. And so coming to that conclusion at the end, all it's really saying is there is an association at best. Okay. Right. They did not. There I go again, trying to be certain when there's no certainty in statistics. But when you see something like, if you eat this amount of chocolate, this will happen. The only way you would ever get to say that is if they took two groups of people, gave some of them chocolate, some of them placebo chocolate, and then followed those outcomes. And that is almost never the case, almost never. Establishing causality in statistics is insanely difficult. Right. It is incredibly difficult. And in fact, it took like 30 or 40 years for them to establish a connection between smoking and bad.
Right. Which now we take for granted, right? I mean,
most people do. There are still certain groups that say it's malarkey or whatever, but I am on the, pro bad. Well, I can't say pro bad, but smoking's bad. I'd rather that. But it's tough. It's really tough to do. So when you see this, and it's constant, I mean, anytime, and it doesn't matter what news you're looking at, what headline or what paper or, what cable show, there's always some little anecdote out there, which really is all it feels like to me, but telling me that if I behave this way, this is going to be my outcome. And it's not. It just really isn't. And it's tough as someone, and as we've talked about, I'm not a statistician, but I do teach the class, the entry level stuff, and it's just tough because a lot of these studies, if my students turned this in for a project, it would not go well for them. And somehow it makes its way into mainstream media, and it's tough. It really is, especially when I see stuff that that I might personally agree with. And I'm like, oh, wow, this
Right.
totally reinforces
Yeah.
beliefs and ideas. Well, but I'm the guy that's like, well, let me check this out.
Yeah.
And I go and I open it up, the actual study, not the news reporting. I skip that altogether. I open up the actual study, and within a paragraph or two, you can usually figure out if it's worth your time. And unfortunately, a lot of it just isn't. It's not. Doing a real well-designed experiment is very, very expensive, both in dollars and time.
And time. Yeah.
So yeah. Oh, the time is incredible. So yeah, it's tough. It is.
So, I'm sitting here wondering what the heck placebo chocolate would taste like.
Oh, yeah.
But B, yeah, probably terrible. But B, it sounds like, and obviously we're talking in very broad generalities here.
Oh,
so
sure.
We'll caveat that. It sounds like often it's not about the study per se. The study authors, the scientists doing the study, whether it's a survey on the phone, like you said, or a controlled trial, either way, they're doing their best to do meaningful science. Mm-hmm. But sometimes it's that filter, that lens of the news reporting and media on top of it, if I'm hearing you correctly. And so let's start today's, tips, tricks, tactics, elements of how to see through some of this stuff, since we're in election season. Mm-hmm. What can people do when they get that article, whether it reinforces their belief, like you said, or it works against their belief? What's sort of step one that somebody could say, wait a minute, I need to look at X, the size of the study, or what are some of the key things people can look at to say, should I just throw this out?
Yeah. So, that's a great question. Honestly, I would say take my class, but
all right. So take your class, but they may not have time for that between now and voting day.
So the most important thing, and I think by far the most important thing, is you got to look how the data was collected. Well, okay, let me back up just one step. You've got to toss the news article that you read, out the window.
Okay.
That's got to go. The only thing that is good for is finding the citation to the actual study.
Yeah, bringing it to your attention.
Find the actual published study. Okay. If it's peer reviewed, great. That's very, very helpful. But the first thing I would do is look at how the data was generated. I used to be pretty big into physical fitness prior to COVID, and I would read all these fitness articles and studies and all this, and in the abstract or the first paragraph, it was like, well, we took 7 highly trained college athletes. I'm like, oh, okay, oop, yeah, 7 highly trained college athletes. Well, I don't fit anywhere in that. I'm 46, so. Right. I'm obviously not a highly trained college athlete. Cool. None of this applies to me. I can throw it out. But the data collection process is I would say it's got to be the toughest part. Toughest part of statistics. There are so many kind of built-in booby traps that are there to just kind of damage the integrity of the study. They're all over the place. One is just the basic being so labor intense.
Right.
Okay? Any data that's been gathered conveniently can almost always be thrown out. If
it was convenient to the researchers.
Right. Yeah. Convenient to the researcher. If you're trying to get a feel on people's political opinions, as an example, and you go stand in front of a church in rural Mississippi, that's not good. Your data's garbage.
Right.
Or on the other side of that, if you go into the Castro in San Francisco,
right,
and ask, these people, I mean, come on, what are you expecting?
Right.
The way things, are supposed to be done, everything has to be random, totally randomized. But randomization is difficult, especially if you're trying to get it at a really large level. So the data collection is critical, and the unfortunate part of the data collection is it doesn't matter how elegant or profound your statistical work is on that data. If you start with garbage, you end with garbage, and there's no way around it.
Right.
You know, bad data is, I mean, that's your source. You're always going to lose, no matter what. There's a few things you can do to mitigate bad data, but in the end, it's still, you're crunching numbers, but the numbers are bad to begin with. So data collection, one, it's tough. But two, it's absolutely crucial. So everything has to be randomized, and then you got to clean up your data, and then if everything is perfect, which it almost never is, then you start doing the stats part. Well, not the stats part, the mathy stuff, the analysis, the organization,
right?
All of that. But what lends itself, that, again, trying to get back to causality, everything has to really fall into place for someone to be able to establish causality. And then, this is a kind of a big deal in academics now. Well, it has been for a while, but replication studies. Nobody wants to do what someone has already done. So with some of these observational works, the ones that were kind of no one's going to do that again.
To repeat it,
you want to be the first one there
again, right? Yeah.
Especially if there's funding tied to it, I'm not. No one's going to give me a grant to repeat someone else's research. To basically fact check it. So you're able to just crank out these studies left and right, and they may or may not be good. So the data collection is a huge part. So if someone was trying to, is this worth a read? Look how the data was collected. Another big one, and this one got me one time. If you can find out if somebody's paying for the study, probably need to really be careful. It would have been 2010 maybe, and I don't even know where I found this. It was some news headline about how after what was that explosion in the Gulf of Mexico? The big Horizon.
Yeah, Deepwater Horizon. Yep.
Yeah, whatever, Event Horizon. But yeah, I mean, it exploded and billions of gallons of oil into the Gulf Coast, and I had just left Florida, living on the Gulf side, and I knew people, and it was horrific. It was horrible what happened, but it was no joke. It was like a year or two later, I clicked on this headline somewhere, and it was like, oh yeah, Florida Gulf. The Gulf of Mexico has been completely rehabilitated, and it's now even less polluted than it was before. And I'm just like, what? And I read part of the article, found where they said the research came from. I clicked on it, was able to get by the paywall to read the study, and at the very end, it was like, yeah, funded by BP.
Yeah.
Oh, okay. All right. Yeah. So, and see, that's another tricky thing. People are fighting for grants. They're fighting for money, right, and stuff like this. And I don't want to put a negative spin on this, but if, say, a tobacco company wanted to hire me to do a study, I imagine any future employment with them and I could be completely wrong, but I feel like, and it doesn't even, it can be anyone, Sierra Club, it doesn't matter
Right.
who, you know.
Yeah, pick an organization.
Yeah, pick an organization. And I feel like, and maybe this is just me being a tiny bit cynical, but if you don't give them kind of the result that they want, then you know, am I going to get another gig? So
Right.
that's,
Well, a couple things in there. You said a couple great points, and on that last point, that goes back to me to what my guest in episode 4 talked about, and it's like talking about the efficacy of a cleaning tool in a hospital, and it's like, well, it didn't do what the study didn't prove what you set out to prove. You say it proved something else, but it wasn't designed to study that, and so that, I think, is buried in your point there, that perhaps if you are getting funding from a company, an organization, a nonprofit, whomever, right? You're getting a grant. Maybe you're not going to be able to tell them exactly what they want to hear because the data doesn't show what they hoped it would. But you may reach for some other related positive conclusion that company could still draw. So it's not like you're not falsifying data or something that negative, but as we started, we talked about the use of statistics for not straight up malicious purposes, but just other purposes, and that might be one way that would manifest, I would think.
yeah.
The other thing that you kind of mentioned there when you were talking about the use of statistics and the design and how you pick the people who are going to be in it and the randomization and so forth. I wondered, this is for what we're talking about now is to prove causation, to prove a certain diet, a certain food, a certain medicine does or causes a thing. But what about polls, political polls, survey polls? I wouldn't think that you can do some of the same, because you're not necessarily trying to prove causation. You might be trying to prove who's going to win the upcoming election. You might, future forecasting or something like that. So just some of the rules you're talking about apply or not apply to the world of polling.
So to an extent, yes. It's not nearly as, I would say, dangerous as an observational study, but you still need the randomization. Again, if you're trying to figure out, how does the country feel about candidate A, we'll just go back to that rural church in Mississippi or the Castro in San Francisco. Okay, so randomization is still a big deal there.
Right.
But I feel like polling is at least somewhat a little bit safer. Sometimes what people will do, and when they do exit polling to try and predict, call an election early.
Right.
They'll have people standing outside the polling area, which is absolutely not random. I'm in Virginia. I'm in rural Virginia. So somebody standing outside of my polling area is going to get something different than if they're in Richmond or Northern Virginia.
Right.
By DC. But, aggregating all of that data, they can make some pretty decent predictions. And as long as, the questions are straightforward, that's another way. You can actually generate data how you want it just by asking a leading question. As long as it's something simple, do you prefer candidate A or candidate B? Then that's a fairly clean question. But if you're like, are you okay with candidate A dumping oil in the river, or giving billions to Wall Street bankers, or, there's a way to lead people, because who's going to say, well, yeah, cool, awesome,
Right.
I'm good with that. So the polling is usually pretty good. My favorite guy to take a look at is Nate Silver at 538. He actually has his own kind of proprietary system. No one really knows what he does, but he's pretty accurate with his statistics and his analysis of things. So I like to check out there. And
I can't remember. Wasn't he one of the only ones who called the 2016 election going for Mr. Trump rather than for Mrs. Clinton?
No, he actually called it in the right way, though. And this, again, goes back to the media not having a clue what they're talking about.
Mm-hmm.
No statistician said Hillary Clinton was going to win, because that's not how statisticians work. Okay? The media was saying that.
Okay.
Nate Silver said Hillary Clinton has a 70% chance to win. Okay? Okay, cool. What is the implication on that, though?
Yeah, what does that mean?
Trump has a 30% chance to win. So 3 out of 10, that's not bad.
Right.
You know, but no statistician worth their salt would be like, this is going to happen. Because that's one of the big, well, and I wouldn't say drawbacks, but it's really one of the things that separates statistics and math. Statistics, there's no certainty anywhere. And you even speak when when I'm doing experimental design and stuff with my students, you don't ever speak in terms of certainty. You're like, well, kinda. You throw a lot of kindas in there, and
kinda, maybe, it's likely.
Yeah, it's likely, or on average, this is what happens.
Right.
But again, it really goes back to kind of that pop science in the media, where they honestly they just don't really understand. That's why, again, people are shoveling chocolate down their mouths thinking
sure
healthy, or red wine, drink a gallon or a bottle of red wine a day, all these things, and none of those were done with experiments.
Right.
So,
to be fair to our friends in the media, I'm not sure how much the average person understands statistics, which is why I wanted to talk to you today. I mean, so, and to that point, you teach stats, but you're the chair of math. You teach math and math more broadly. And I saw a TED Talk once where there was a mathematics professor there who was advocating that rather than having like calculus and physics be the top of the pyramid in American academics for math, at least for like through high school. I don't remember exactly what grade or what level he was advocating, but essentially for the average person rather than for somebody going into the STEM fields, that we move calculus and physics out of that capstone position and put statistics and probability into that capstone position. How do you feel about that stance?
Torn. There can be some religious fervor among academics, and when that's questioned, there's some blowback. I try to be open-minded. I am a STEM, calculus, physics type of person. I love it, but I would have to go out on a limb and probably maybe even betray myself a little bit. I don't think it's a bad idea, honestly.
Because I think his point was that the applicability to day-to-day life is much higher for stats and probabilities because of like what we're talking about. Understanding if you're being misled either intentionally or unintentionally. Understanding the world around you. Understanding that perhaps the lottery is not the best retirement plan. Things like that. I think is why he was advocating this stance, whereas physics and calc are great insights into how the universe works, how engineering, how the mechanical world around us works. But not everybody needs that every day.
No, I as far as, and again, to betray myself here, but as far as like a K through 12 education, I mean, obviously, the basic arithmetic and all that. But I do think there needs to be kind of a refocus. Algebra, algebra is really the kind of the foundation to move into calculus. You
Right.
kind of do some algebra, and then you do some pre-calculus algebra, and then some trig, and then you hop into calculus, and you're off to the races for your engineering degree. Well, that's not most people.
Right.
And as much as I'm a fan of that STEM path right there, you know, the average person, oh man, I can't believe I'm going to say this, but algebra is just probably not what they need.
Yeah, I don't remember my binomial functions. I'll admit. I mean, or if I'm doing some of that, it's in Excel. I've got software tools these days because
sure,
I do a lot of stats and probability and math and so forth at my work. But I'm not an engineer. I'm not a, I'm a healthcare finance guy. So it's a lot of budgets. It's a lot of things like that. And there's an awful lot of algebra that I have probably forgot. I probably don't even realize how much I've forgotten.
Yeah. It is, and it's unfortunate because when I did teach, a college algebra course, or even the developmental math courses, they're all algebra. It's all algebra based. And then I get the inevitable question: what am I ever going to use this for?
Right.
And honestly, there has been so many times where I'm like, well, if you're going into a STEM path, you have no choice.
Right.
Okay. This is what you're going to do. But then, there's a big portion of the class that's not doing STEM.
Right.
And they're like, well, what am I supposed to do with it? There used to be, back in the olden days, like a financial literacy math, balancing the checkbook.
Yeah.
And I think what's most important today, for the people who aren't going to use any math at all, math for daily lives, especially like amortization of like loans and stuff.
Interest.
Because now, if you drive by any car lot, they don't have the price of the car on there. They have the amount of the loan payment. And all that's a booby trap right there. Right? $250 a month. Well, no. I don't want to know $250 a month. I want to know how much am I paying total.
Right.
And we've got a fundamentals of reasoning course, which is actually kind of like that, but no one's required to take it. And in that fundamentals of reasoning course, we go through car loans, and I've pulled this up before, where you go in and they ask you, well, how much can you afford a month? And that is not what you want to hear. Because if you're buying a $15,000 car and after 7 or 8 years, you've paid $40,000 or $50,000 for it,
right?
Because all you concentrated on was that payment,
right? Interest.
Then you just got creamed.
Yeah.
So, I would have to agree with something like that. And then statistics, for the very reason of the whole media bombardment. I think it would be great, because then all the stuff that I read other people kind of saying and posting, like I said, any time I see a statement that's politically charged, or I look at the study. What does the study actually say? And a lot of times it's I don't want to say it's completely useless, but it's very weak. And a lot of it goes back to that poor data gathering. If you're sending out a voluntary survey, that's a big way to gather data, is a voluntary survey, which is just not good. I get emails all the time from people asking me to take their survey, and I've only ever answered one. And it was from a PhD student at the University of Missouri talking about gun violence on campus. Why was that the only one that I answered? Well, because it meant a lot to me.
Mm-hmm.
You know, if I get a survey randomly in my email from a PhD student, you know, wanting to talk about my pregnancy, you know, it's like, okay, I can throw that away. But I'm I don't want to say, but I'm kind of passionate about guns being on my campus and in my classroom. So
Sure.
I answered it. But I tossed the rest of them away because I don't really care. So when someone does a study using data that was gathered voluntarily, you get the extremes on both sides of the issue. You don't get someone that's ambiguous. They're just like, no one answers that.
Right.
But if it's something that means a lot to someone on the positive end and it means a lot to someone on the negative end, they're diving in. You know, I answered that questionnaire because I don't want guns in my classroom, which I think is fair. So that's another avenue of that data collection. Did they call people? Did people randomly just say, well, I'll answer this survey? I mean, there's
who answers their phone anymore?
To do it up. What's that?
I said, who answers their phone anymore? You know,
I know.
a phone-based survey. Just to your point about how these things can bias the responses, right?
Oh, sure, absolutely.
And you know, when you were energetic about that particular survey, which probably a lot of people who responded were, and so
sending it out to only academics and teachers. You know,
right?
If that's all you're doing, I would imagine quite a few people don't want armed students in their classroom.
Right.
I could be stretching it a bit, but there's so well, and I think actually probably the most famous example of this was that Dewey defeats Truman. I'm pretty sure it was that. And what the polling agency did was they went through it was like vehicle records or phone books. I think they went through the phone book. And it was very expensive to have a phone at the time. So what they ended up doing was calling some fairly affluent people, and their whole data set was all these people that could afford phones.
Okay.
And they voted overwhelmingly for the candidate that ended up losing. And the whole polling agency just...
President Truman. So you're talking what, 44? No.
Yeah, I think it would have
45, something like that.
Yeah, it would have been 45 or 49, somewhere in there. And that's just a fantastic example of, you know, a polling mishap.
Right.
Just get names out of the phone book. Well, when not everyone has a phone, you know, that narrows that demographic quite a bit. So it is really, really hard. And I know I've kind of been probably mean to a lot of the people, you know, that are doing this stuff. And I guess some is maybe better than none, but it is hard. It's hard and it's expensive to do statistics well. And then even in the reporting aspect of it, you know, like I said, there are so many ways for this stuff to really fly off the handle. One of the examples I use in my class, you know, if you saw a headline that said, you know, the murder rate doubled, okay, is that bad? Sounds bad. It sounds terrible.
Yeah, sounds awful.
Yeah, that should you move, you know?
Mm-hmm.
And the thing is, this could absolutely be true and be completely meaningless. Okay?
Mm-hmm.
What if the murder rate was 1 in 100,000 people? If it doubled, it was 2 in 100,000 people. And except for those 2 people, this isn't bad.
Right.
You know, but it's still doubled.
Right.
So you can get a sensationalist headline that's not a lie, but it's insignificant. It's meaningless.
Right.
Like I said, except for the 2 people. I feel bad.
Yeah, obviously, that's so. A couple things again. I think, obviously, that's one of the challenges I think of statistics, of economics, is it's kind of cold, right? So like that example, the murder rate or the COVID fatality rate over the last couple of years, that's been obviously was something in discussion. More politically charged, so we won't stick on this very long, but, gun violence, certain elements of all of these topics are truly tragic to anyone directly or even second order, affected.
Oh yeah, for sure.
But when we look at something statistically, maybe something a little safer, Ebola deaths in Africa, right? Pretty distant from us. So maybe a little safer to talk about. If there is an increase in Ebola deaths, it may not be frightening. And we've seen that where Ebola is, there was like the one case a couple years ago that the person came over on the plane to the United States or whatever. It's like, oh, okay, one case in 40 years in the United States? One? Or I remember as a kid being terrified of sharks, in the beach, for the, 2 vacations my family took to the beach. I had read a book about sharks. I mean, how many people globally die from sharks every year? Like nothing. Right.
Yeah,
so to your point, I think the human brain just doesn't work well to understand some of these risks and the relative values of an increase or a decrease in risk. Oh, it doubled. Oh, it went down by half. Right. But, okay. Some of these things are really small. If they're larger, though, obviously that could go the other way. Oh, it only decreased by 2%. That's not a big deal. Well, except if 2% in, what is it, like 1 million people a year die from heart disease. So if we could shave that mortality rate by 2%, that's a big deal. That's a lot of lives, so it could go both ways on that. Is that fair enough to say?
Oh, yeah, definitely. And you actually mentioned something about, the human brain, which is a fascinating marvel of the natural world.
Right.
And it's also insanely weak, which is such an interesting paradox. But I think this came out of a psychology journal. But it was like in the 50s and 60s, during the height of the Cold War, some researchers, and this kind of blends in with the leading question thing. Some researchers designed this super cool kind of study, and what they did was they grabbed a group of Americans and they asked them, the very first question they asked, should Soviet journalists be allowed into the United States to, report? To be journalists, yeah. Yeah, do journalist stuff. And the overwhelming response was, oh, God, no. Oh, no, the enemy? We're going to let the Reds in? No way. They followed this up with, should American journalists be allowed into the Soviet Union to do journalist stuff? And the response was, well, I mean, if we're not going to let them in, I guess we probably shouldn't go over there, And so they did that for a while, and then they flipped it. And the craziest thing happened. They asked the new group, should Americans be allowed? All they did was change the order. Question. Should the American journalists be allowed into the Soviet Union, to do journalist stuff? And the overwhelming response was, well, yeah, freedom, blah, 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 yeah, of course. And then, should Soviet journalists be allowed over here? And they're like, well, yeah, of course they should. And reading it, I'm just like, and see, the thing is, if you ask a bad question, you can fix it. Right? When we talked about, would you vote for this guy who dumped a bunch of oil in the river, the drinking water, you can fix that by just cleaning it up. But those two questions, you can't fix that.
Right.
Like how do you solve that problem right there? Because you ask it in one order and you get wildly different responses to switching the order. And they're the same question. I don't know. I mean, there are absolutely limitations to this. It's fascinating. I think it's very, very fascinating. Yeah. So there's even if you do your best, I said data collection was hard. Even if you do your best, yeah, I mean, you might just be hamstrung from the get-go. What if you really wanted to know, like, what does the public feel like about letting so you won't get a straight answer unless you leave out one of the questions. But then that kind of screws up the little study they were doing. So
yeah, that's fascinating. And I'm sure there's other experiments that have done similar work on the impressionability of the human mind. And
if the first question poisons the well for the second question. Yeah, that's exactly what happened. So yeah.
So speaking of limitations on statistics and combining that with your point earlier about the sort of bias in the results that comes from energetic or motivated respondents, should anybody bother with any sort of online review? And by that, I mean, so not to pick on any companies, but Amazon's, I always try to shop for stuff that's got 4 stars on Amazon when I'm picking a product, or you want to go to pick a restaurant in a new city and you go to Yelp or whatever. But the people responding are probably motivated either to get 1 star because this was a garbage product with garbage customer service, and I give it 1 star, or it was so great I'm giving 5 stars, whatever. How many 3s are really out there? And so again, we're talking in generalities, but do you think that some of the limitations that we've talked about imply that a lot of these ratings online don't have a ton of validity, I guess is how I would phrase that question?
Well, so I would agree in 2 different aspects. One, the aspect you just mentioned. It's you're going to get the wildly energetic person to drop the review, and then even on some of the Amazon reviews, I've read product didn't arrive on time. I'm like, I don't care. Tell me about the product. So and then you've got all the Amazon, maybe not Amazon bots, but you have the third-party bots, and they're just so Amazon reviews. That would be tough. Same with Yelp. There's a fun, very, very fun short. I can't remember who this kid is. He created a restaurant in the UK that didn't exist. And oh my goodness, this is one of the greatest troll jobs I've ever seen. But he created a restaurant in the UK that didn't exist. He went on Yelp, flooded it with amazing reviews, and he was able to get this non-existent restaurant not only to the top of Yelp, but to get local news rags talking about how exclusive this place was because he never took one single reservation.
They're so exclusive, they don't even exist.
Yes. I think it's on YouTube somewhere. And listening to this kid, it was hilarious because he was like, I'm gonna see if any Yelp reviews are worth it. And with a little bit of there was, I wouldn't say malice, but he was just trying to test the system, and he did, and it honestly, it was very, very funny. Maybe not for the people who got taken, but those online reviews, those can be dodgy for both reasons, right? The reason where it attracts, think about the reviews maybe that you've left. And speaking personally, it was either a 5 or a 1.
Right.
Honestly, it really was. It was either a 5 or a 1. And the only reason I could think I'd ever give a 3 is if I started with a 5 and then it broke like a week later, and then I went back in and changed it or something like that, you know? So it is tough. Yeah. Yeah, I never even really thought of that, but it's the same thing.
I hadn't either until we're talking today, and so that's so then you start to wonder, like, should companies even bother? Should they even care? I know some companies are really aggressive with their social media departments. They want to respond to bad Facebook reviews, bad Amazon reviews. Other companies are just like, yeah, whatever. And it really, some of what we're talking about makes me wonder, is the investment in even bothering with these things viable?
Worth it.
Worthwhile.
Yeah.
Conversely, if you don't, a lot of, I think, market expectations are that companies are responsive. And so you do have to kind of deal with market pressure. So, but yeah, I'd never really thought about the correlation between the limitations of statistics, the selection bias of energetic respondents, and how that combines to cast doubt on some of rating systems that we take for granted in the retail and commercial space. So that's interesting. Okay, so we've got some tips for folks. We've got, you know, an election coming up. There's polls out there. We have science every single day, journals, dietary guidance, nutrition guides, you know, and we've got today, don't look at the article, look at the study. If you can, look at who's funding it. Look at how the data was collected. If it's, you know, phone studies, and if it's convenient to the researcher, it's probably not worth putting a lot of weight into that. We've got just understanding that nothing when it comes to a poll or statistics is a guarantee, that it's more about likelihoods and probabilities, and keeping that in mind. And then we have a grain of salt when it comes to online reviews, ratings, and so forth. Any other tips, tricks, techniques you think the average person should keep in mind, you know, to kind of close out our time together?
Honestly, have an open mind and be curious, not just, you know, the things we talked about before, but actually pursue these things. Be curious. I have strange political beliefs, and I feel like both sides don't really dig with me. And so sometimes on social media, you know, one side says this, I look at the study and I'm like, well, did you see this and this and this? And then the other side says this, and I'm like, whoa, what about that? You know, you have to be willing to challenge your own beliefs.
Right.
And I know so many people, they see the headline, this agrees with me, and they just put it out there, and that's it. No, you know, I honestly, like, we shouldn't be on different teams. We should be pursuing truth.
Right.
You know, let's figure this out. You know, I'm not just going to believe something because my team said it. You know, and in fact, I'm a lot harder on whatever my team is, but I'm a lot harder on that because I don't want misinformation, because anyone else with just a little bit of skill can look at this and go, that's garbage.
Right.
And then that doesn't do, you know, my thoughts and beliefs any justice. So have an open mind and actually pursue truth, and be willing to change your opinions if the data suggests otherwise, you know, and yeah, man, just go for it. And never, well, I don't want to say never, but usually the like you said, the media article is not very good.
Yeah.
Find the actual study. Read that. That's the starting point. Find the actual study. And you usually can. A lot of times they're behind very expensive paywalls.
Sure.
Like $40 to $100 to read it. But I just read, I think it was yesterday. I think by 2025, all federally funded studies, which is almost everything at the university level,
sure,
are now going to be seized, and they will be free.
Which makes sense. I mean, your tax dollars in some way, shape, or form.
I've never understood. if especially, well, in any academic discipline, if the university produces it with taxpayer dollars, how does someone else get to take that research and charge the public to see it? I funded it.
Right.
Right. What do you mean? Like, and I know other people, just all across academia, are like, I don't know how is this possible?
Right.
I have access to a lot of stuff because I'm an employee.
Right. Because you're part of the academic.
Right.
You're inside the wall.
Yeah. But the money doesn't go to the universities and colleges either. It's some private third-party entity that somehow, I don't know how they get the research, but they get it and then they just put up a paywall. Oh, you want to read it? $50. Like, no, dude. No. It's weird, but I think by 2025, that's supposed to be gone.
That's good.
Hopefully the floodgates will just open and people can look at everything that's out there, and then, hopefully, decide for themselves, or at least get a better idea of how things were done.
Yeah.
Instead of just hearing it on, their news channel and going, okay, well, that's true. There's a study. Well, there's all kinds of studies. I mean,
there's all kinds of studies.
What was it? The lobotomy won a Nobel Prize. So, it's not.
I'm not familiar with that story. Well,
I don't know. I might be full of it, but from what I remember, the lobotomy, like 70 years ago, got a Nobel Prize, and now it's like, oh, well, maybe we shouldn't be doing that.
Yeah, there's a lot of fields where, as time goes on, we've realized that, maybe leaching, for example, in the medical field, a couple hundred years ago, it was important to get drained of your blood from time to time, and so norms change, ideas change,
Yeah. Oh, definitely. And I think that we have to change with those things, and which was kind of that whole point of having an open mind,
Yeah.
Don't look for things. Well, and you know what? That is the one amazing thing about statistics. One thing I truly, truly love about statistics is that if you're going to be critical of it, you do not criticize the conclusion. Useless. Don't criticize the conclusion. You criticize the methodology, which is kind of read, how they get the data, what's the sample size, all of that stuff. You don't just attack the conclusion because it disagrees with you. That doesn't make any sense. You've got to dig in there, and you've got to jump into the methodology and just be like, oh, well, you guys might have did this wrong, or something like that. So it's not like philosophy or something where you kind of attack. Well, I shouldn't say that. I mean, I have a degree in philosophy as well, but
I think your point. Philosophy is often driven by the individual thinker.
Sure. Yes.
And statistics, to your point earlier, to your point throughout the hour that we've been together, is so much of it is about the inputs. And that has a degree of separation from the individual thinker. Now, they could put their finger on the scale, like we said, but ultimately, I like that point about criticizing the methodology rather than the person, because that's the other thing is just we live in a time that there's a lot of anger between parties. And so I think that's another nugget we can leave people with, is just try to be objective, not only open-minded, but objective in how you approach.
Sure. Definitely.
So, well, Adam Becker, I appreciate you being with me today. I love the conversation. I hope that folks learned something to separate the wheat from the chaff, as we say in the Midwest, when it comes to all the data out there, all the polls, all the everything heading into the November midterm elections, or just for your daily life. So thank you for being here with me on No Bad Questions.
Thanks for having me.